Morning, everyone. Are you hearing me? Hello. Shall we start? Yep. So, myself, I'm A. Srinivaslu, and having 10 plus years of experience. I'm having experience in Java and Java frameworks. Uh, Around 4 years of experience on 4 years experience on Hadoop and Hadoop administration, and both Hadoop development and admin. And last 1.6 years, around 2 years, of experience on Spark and Scala development. Spark and Scala development along with the Java integrations. So I have experience on NoSQL databases. I worked on Cassandra. I worked on HBase. I worked on Redis. And I have experience like Kafka. I have Kafka with Java, Kafka with Hadoop integrations, Kafka with Spark integration. I have experience. So I'm very good at streaming technologies. What is Hadoop administration and what we are going to learn in this Hadoop administration? This is not complete Hadoop administration. Here I'm saying Apache Hadoop administration. What is this Apache Hadoop administration? What we are going to learn as part of this Apache administration, how it helps to Hadoop development and Hadoop administration, complete Hadoop administration, and Spark and Scala development. Okay, so here we are going to discuss what is this Apache Hadoop course, how it helps for us. So Apache Hadoop, first Hadoop vendor is Apache. Apache is a Hadoop vendor and it is open source. It is open source. Apache is a open source and free. Free means there is no need to pay any license cost. There is no license cost. License cost. On top of Apache Hadoop, there are some other vendors. Vendors like Cloudera, Hortonworks. Now Cloudera and Hortonworks merged. Now Cloudera and Hortonworks merged. Earlier both are different vendors, and we have another vendor, IBM. IBM has its own big data called Big Insights, and we have other vendor, Microsoft. Microsoft has its own product called HD Insights, and we have main popular vendor. I forgot that vendor. It's Mapper. Mapper is another big competitor for Cloudera and Hortonworks, and we have AWS EMR. Like this, we have multiple vendors. All these vendors backend is Apache Hadoop. I said Apache Hadoop is open source. Open source means they give us complete source code. They give complete source code. Complete source code of Apache Hadoop implementation. Apache Hadoop implementation. So based on this Apache Hadoop implementation, they have provided enterprise versions with different additional features. These vendors provides user interface differently and administration differently. They provide different user interfaces and they give us as an enterprise version. So it's complete, Apache Hadoop is completely free and open source. On top of this, they provided some wrapper UI. Okay. Other than that, every vendor backend is backend is Apache Hadoop only. Every vendor backend is Apache Hadoop only. Okay. So these are different popular vendors in the market. They provided Hadoop on top of Apache Hadoop. So here, as part of our Apache Hadoop administration, first we'll discuss what is Hadoop, what is Hadoop, and what is big data. What is big data? So big data is very important. So big data is a concept. On top of big data, to implement that big data, we have a Hadoop. Then we discuss, we understand what is Hadoop, and next we start with Hadoop architecture. Hadoop architecture. Before Hadoop architecture, we'll discuss very important concept, Hadoop features. Why we are using Hadoop? So there are many features. There are many features. Because of these Hadoop features, people are going for Hadoop. So first we understand what are different Hadoop features, why people are going for Hadoop. Then we discuss Hadoop architecture. In that Hadoop architecture, we discuss various Hadoop components or different Hadoop components, different Hadoop components, different Hadoop components. Then once we understand Hadoop architecture, next we start Hadoop installation. In Hadoop installation, we have different types of installation, local mode and pseudo distribution mode, pseudo distribution mode, and we have fully distribution mode, fully distribution mode. We discuss all these modes because it is very important. We discuss all these installations of Apache. We discuss local mode, Apache Hadoop installation, and pseudo distribution mode, Apache Hadoop installation. Next one, fully distribution mode, Apache Hadoop installation. So because if you understand Apache Hadoop, remaining vendor is same, almost same. Then additional we discussed high availability concepts and different other concepts, monitoring concept, troubleshooting concept with any one vendor. So first these 10 days we concentrate on installing and configuring Hadoop in a single machine, in local mode and pseudo distribution mode. In fully distribution mode, before coming to this installation part, we need to discuss some prerequisites, right? So prerequisites we discuss. Prerequisites for Hadoop installation. So as part of this prerequisites, Java is mandatory, Java installation. So we see this Java installation on Linux. So before installing this Linux, we go for Java, we go for Linux installation. On top of Linux, we do Java installation. Next, SSH installation, SSH configuration and installation. If required, we'll discuss SSH installation. So next, very important one, some networking concepts is important. Networking concepts. So these networking concepts I cover as part of fully distribution mode, because we create multiple missions like this. In Hadoop, in fully distribution mode, we have master daemons and slave daemons. We have some master daemons and slave daemons. So we create master daemons in separate missions and we create separate slave daemons. So Hadoop follows master slave architecture. Hadoop follows what? Master slave architecture. So we take multiple masters and multiple slave missions. So we take some missions as master missions. So what are different master mission components in Hadoop? We discuss as part of Hadoop architecture. So in Hadoop architecture, I will explain clearly what are different components available, what components acts as master missions, and what components acts as slave missions. We get a clear understanding in Hadoop architecture discussion. In Hadoop architecture discussion, I will clearly explain what are components comes under master and what are components comes under slave, what is each daemon responsibility, how it behaves in cluster, what are each uh, component roles and responsibility in Hadoop cluster, so that we understand in Hadoop setup. So we are putting simple Hadoop architecture, but we are going to discuss very in depth, so that you will understand. This knowledge will help you in Hadoop development as well as Hadoop administration, in Spark development also. Okay, so that's why I concentrate more on this Hadoop architecture explanation. Next, Hadoop installation is very important. For Hadoop installation, we need some prerequisites. Okay, as part of networking concepts, I cover, for example, when we discussing Hadoop distribution mode, pseudo distribution mode, we need some commands. In fully distribution mode, we need some commands. So at the time of discussing, I'll cover what are required, what are important network commands, means Linux related networking commands. We discuss all those concepts as part of fully distribution mode. So this installation is very, very important for both developer and Hadoop administrator. Because assume you are a developer, you are working in a small company. So we cannot see a separate administrator, Hadoop administrator. So both developer acting as a developer plus admin. That's great opportunity in small companies or startup companies. If you go for MNC, they cannot give a chance to, if you are a developer, they cannot give you a chance to work on Hadoop administration, because Hadoop administration is different to team. They sit in different location. They may sit with along with us, or they may sit with different. So we don't know where exactly they are. So administrator doesn't know where developers are. Yep, let me explain, Srinivas. So testing part is very important. Up to now, we don't have a separate tools. We use first we use manual testing. It's mandate. Next, we use some automation tools like we have JMeter, some other tools. So we use those tools for automating Hadoop development. And For Spark, we can use any testing framework. For Spark development, we can use any testing framework. I'll come later. So as part of prerequisites, I'll cover all these concepts. And next, in a fully distribution mode, we spend more time on fully distribution mode explanation. In fully distribution mode, the great advantage is in Hadoop is, see, initially we create a cluster with these missions, 3 masters and 5 slave missions. Initially we create a cluster with 3 masters and 5 slave missions. Later, client business is increased. We want to add multiple missions to existed cluster. So initially cluster thinks that 5 slave missions are enough for storing data, because his business is less, so he buy only 5 slave missions to store data. Later business is increased, then he need some more missions to add to store his transaction data, right? So for that one, if in existed architecture like RDBMS cluster, how can we add new missions to existed cluster? How can we add new missions to existed cluster? We need to stop, or we need to put cluster in maintenance mode. Means in that maintenance mode, no one can do any transactions. Then we can add new missions to cluster. 1 minute. Yep. New missions to cluster. Then we can start cluster. So that is the drawback of existed architecture. But in Hadoop cluster, you can add any number of missions and you can remove any number of missions from Hadoop cluster without stopping Hadoop cluster or without putting Hadoop cluster in maintenance mode. So we are going to see different operations. 1 minute. Sorry. So in fully distribution mode, we discuss installation on different Linux machines. Mostly we take 5 nodes. 5 nodes. Sorry, we take 5 node mission. These 5 nodes we create in VMware. So VMware is important. So first prerequisite, we see any virtualization software, any virtualization. So as part of this virtualization, we see VMware setup and VMware workstation installation. In that VMware workstation installation, how to install fully distribution mode means we take 5 missions. In that 5 missions, we take some missions as master missions and we take some missions as slave missions. Then we create fully distribution mode. Next, here very important one is, once we complete this installation, we do hdfs commands. HDFS commands we are going to discuss after completing all the setup. So here after installation, next level, we are going to see how to add or remove missions or nodes to cluster. We are going to see all these how to add and how to remove missions to cluster. So we are going to discuss this one. After that, next very important, client missions. So we have a cluster. In this cluster, we can take any mission as a client mission. So this is our Hadoop cluster. Hadoop cluster. Assume this cluster may be uh, on premise. So we'll discuss what is on premise. On premise means if client maintains a separate data center with their own missions, we call it as on premise or cloud. So we have a this cluster in on premise or cloud in separate location called UK. In London we have a setup. So in this cluster, they may give one mission as a client mission, or most of the times in real time implementation, they cannot give any one mission as a client mission. In a cluster, they cannot give master or slave missions as a client missions. For that one, what they will do, they will create a separate client missions. They may create one client mission or multiple client missions. They may create one client mission or multiple client missions. Assume they created two client missions. This is client 1. In this client 1 also we install Hadoop. In this client 1 also we install Hadoop. Client 2. Then as a developers, we are located developers or administrators. We are presented in different locations. We have our own mission. Then they give us these client missions URLs. So we execute our commands or applications. In client missions. Any client mission, you can use any client mission. So if you are executing commands in client mission means these commands are going to execute in cluster. So we are thinking that we are executing in this mission, but commands are going to send to cluster. Okay, so we see how to set up clients. So here I'm going to explain how to install client mission. So this client or we call it as edge node. Some people call it as edge node, or some people call it as gateway node. We'll discuss all these concepts in our Hadoop architecture once again, so that you will understand what are these edge nodes or client missions. So here I will show you how to set up Linux client, Linux Hadoop client, and how to set up Windows Hadoop client. So if you have a Windows machine, then you can install Hadoop in your Windows machine. I will show you how to install in both Hadoop and in Windows and Linux. So it preferably you go for Linux. Most of the times Windows are Hadoop client missions. So we install Hadoop. For this any one mission, we take two client missions. One we take as Linux. In that Linux we install Hadoop. Then we make this mission as a client mission. To make this mission as a client mission, what we need to do? That's very important, right? So without doing that configuration settings, this mission cannot act as a client mission to this cluster, right? Yes or no? So we are going to do that configuration part in client mission. So we install Windows and we install Linux. In that Windows, we are not going to install Windows operating system. I will show you only how to install Linux operating system. In your Windows mission, how to install Hadoop and how to make this mission as a client mission to Hadoop cluster. Then here we need some important. If you make this mission as a client, then we get a very important concept called here prerequisites. User management, Hadoop user management. So this concept I cover as a separate concept so that you will get clear clarity. So Hadoop user management, Hadoop user management, and authentication. This one, ACL, access control list. So user management and group management, user management and group management, group management. Plus we are going to discuss access control list, how to give access to users. See, we are creating multiple clients, right? So we want to give access permission on different file system in Hadoop cluster. This is responsibility of Hadoop administrator. Yep, no worries, Sujit. I will clearly explain. This is Apache Hadoop, so that we have everything in our control. So if you are taking minimum of 5 missions, so minimum it requires 10 GB. So you are taking, see, you want to create a 5 node missions. 5 node missions, I said right here, 5 node mission, 5 node missions. Assume if you are creating 5 node mission, you need 5 into 2, 10 GB RAM. So you have a 8 GB RAM, then create a 3 node mission. 3 node mission. Okay. So minimum each mission require 2 GB RAM. It is not for Hadoop. Minimum operating system is required 2 GB. Okay. So that I will explain as part of prerequisite so that you will get clear clarity. Okay. Next we'll discuss user management and group management so that you will understand different how to assign permissions to different users. So developers, we have a multiple developers, right? And we have multiple administrators. So for everyone, we create a separate users here. Then we give permissions to Hadoop cluster. So we create a different users here and we give URL, IP address of this mission and username and password to these developers and administrators. Then when they execute any commands in this mission, Hadoop commands or anything that reflects to this Hadoop cluster, right? So they need permissions. For that one, we are going to learn Hadoop user management and group management activity plus how to assign specific user permissions. So permissions we discuss. So simply we can say I divide this one. I will say how to give permissions. So simply we can say permissions and access control list. We are going to discuss permissions, user permissions and access control list. User permissions and access control list we discuss. Next, after completing this discussion, we are going to discuss Hadoop ecosystems installation. Hadoop ecosystems, Hadoop ecosystems are frameworks. Hadoop frameworks. Hadoop frameworks installation. Hadoop frameworks installation. So we install these Hadoop frameworks not in Hadoop cluster, not in Hadoop cluster. We install these Hadoop ecosystems in Hadoop client missions. In Hadoop client missions, we install Hadoop ecosystems or Hadoop frameworks. Then as part of this Hadoop ecosystems installation, we are going to install Pig. We are going to install Hive. and we are going to install MySQL. Then we are going to install Hive, Metastore as MySQL. What is this Metastore concept? I will explain in Hadoop installation part. So that what is the need of this MySQL and what is this Metastore? How to make this MySQL as a Metastore? We are going to discuss as part of this complete Hive. This is very important for both developer as Hadoop administrator. Next one, some other ecosystems like Flume, Scoop, and we are going to discuss HDFS commands. This complete, I will try to cover these all concepts in 10 hours. I'm trying 10 hours, but 10 hours may not sufficient for this discussing all these components. So max I cannot waste your time. So max I will finish 15 hours. Max I will try to cover all those concepts in 15 hours. Okay. So max you can expect 5 more hours. I will try to finish in 10 hours, means 10 days. If it is not, maximum it will take 15 days. 15 hours means 15 days. 15 days. If possible, Saturday, Sunday, I will take extra time if possible. So we have multiple peoples in this workshop. So based on your convenience time, I will propose time. So then if all of you okay, then we go for that time and we spend more time in weekends. Okay. So minimum of 10 to 15 days. So 10 to 15 days. If we take weekends more time, then it will reduce to 10 days or 12 days. Okay. So once you complete this Apache Hadoop administration, once you complete Apache Hadoop administration, then you can go for big data developer. Then learn Hadoop development, plus Spark plus Kafka. So for learning Kafka Hadoop development, this is not mandate. What I'm saying, once you complete, if you want to go for big data developer, you can choose these kind of technologies. NoSQL for development, or you can go for Hadoop administration. So as part of Hadoop administration, it's recommended go either Cloudera or Hortonworks. It's recommended, but I said both vendors are merged, right? So you can go for Cloudera complete administration, because here 10 hours is not sufficient to become a Hadoop administrator. You need in-depth knowledge of any one vendor. In real time, they may use Cloudera, they may use Hortonworks, they may use Mapper, they may use uh, any other IBM, Microsoft, any other vendors Hadoop system. So you can learn any vendor. Okay. So it will help. This Apache Hadoop administration will give you in-depth idea. so that you can learn any of big data development or Hadoop administration. So both are having same currently both are having same demand. So currently we cannot say Hadoop has good demand, development has good demand, Hadoop administration has less demand. No, both having huge demand. If you are a tester, go for Hadoop testing. But currently industry not using separate separate tools for Hadoop testing. Most of the times we go for manual testing or some other tools like JMeter, and for Spark we use any automation framework. It may be Selenium, it may be anything you can use for Spark. Spark is like a Java kind of a development. So we can use Java, or we can use Scala, or we can use Python, or we can use R language. So for that languages, whatever the automation tool you are using, you can use same automation tool for Spark application development. Okay, but Hadoop development, we go for most of the times we go for manual testing. So this administration concept will help you to enter into big data development or Hadoop administration or Hadoop testing. For this, what is the prerequisite knowledge? Prerequisites to learn Apache Hadoop. Apache Hadoop administration. What are the prerequisites required for to learn Apache Hadoop administration? First, I am saying there is or no need to know any specific language. First important point, no need to know any language, computer language, any computer language. It may be Java, it may be any other. No need to know any language. So we are completely dealing with Apache Hadoop administration. Basic knowledge of Linux. Basic knowledge of Linux. If you know Linux, it's very advantage. Next one, if you have Linux administration, it is add-on advantage. If you have optional, that's what I'm saying. These are optional. If you have a DevOps knowledge, it's add-on advantage. Instead of installing all these systems manually in Assume we are installing 5 missions, right? You can automate this complete process by using DevOps tool. Add-on advantage, it is optional. Sorry. Next one, if you have any cloud means AWS or Azure or GCP, Google Cloud Platform, any other, it is add-on advantage. So it is also optional. So if you have all these skill sets, whatever we are doing as part of this virtualization, you can install. If you know cloud, you can set up the same thing in cloud. If you know DevOps, whatever we are doing manual setups, manual configurations, then you can automate by using any DevOps tool. So most of the times these networking concepts, and we are installing Hadoop in Linux system, right? This Linux admin basic knowledge will give you more advantage. This Linux administration will help you a lot in Hadoop administration. That's what I'm saying. These are optional. First, it is not required. Any computer language is not required. Knowing computer language is not required, because we are not writing any programs. We are not writing any processing logics, right? So for Apache Hadoop administration, it's not required to know any computer language. No need to know Java, no need to know Python, no need to know Scala, any language. But Linux basics will help you a lot. Linux basics will help you a lot. I will share YouTube link, mine. I created around 12 videos. If you get chance, if you get time, try go through that videos, so that before installation, if you go through that 12 videos, it will help you a lot in our Apache Hadoop discussion. I have already created a playlist. Around 12 videos are there. So that's enough for your Apache Hadoop administration, even this Cloudera administration also. Cloudera administration also. Okay. Next. So today I'm going to stop at this point, because tomorrow we are going to start from scratch, so that if any new people will enter, they also understand. Because today we are discussing completely what we are going to discuss as part of this complete workshop. So this complete workshop is free. Okay. Once you complete this workshop, you can choose your career as big data developer or big data administrator, or you can choose direct Spark and Scala development also. Anything. Big data developer means people will expect this skill. If you have this skill, you will get more chances. If you are going for Hadoop administration, they will expect the first Apache Hadoop administration. Then if you understand this one, learning any vendor administration is nothing. You can easily learn. Someone asked a question. Yep. Do you offer Spark Scala development? Yes, I'm offering. I'm offering both Hadoop development and Spark and Scala development, and I'm dealing with Kafka, NoSQL development. For this, I'm going to give Java SQL trainings. Okay. So my skill set, first main skill set is Hadoop development. Last 4 years onwards, I'm working on Hadoop development. I worked on all Hadoop ecosystems. All Hadoop ecosystems except MapReduce. Last 4 year onwards, I didn't get a chance to work on MapReduce. I'm a very good developer because I have complete Java prior to Hadoop development. I'm a Java developer. Around 6 years, I worked in Java development. From 2006 onwards, I am giving trainings on Java development. but I didn't get chance to work on this MapReduce. I got a chance to integrate Hadoop ecosystems with Java. So I worked as a Java plus Hadoop development. Then I worked as a Spark developer from last 2 years, Spark development. And I worked on NoSQL developer. So Hadoop developer means we use NoSQL also. NoSQL development. In NoSQL development, I got chance and work on Cassandra. Initial projects I worked on Cassandra. Later I worked on HBase, and I have experience on Redis. Redis is we used this Redis for Java projects. Java projects. It's in-memory database. So we used it as a Java projects. We use Redis, and I worked on Hadoop administration. Hadoop admin. I worked in one of the startup company. In that startup company, I have this skill. So they asked me to work as a support for Hadoop administration. They taken services from third-party vendor. With them, I worked as Hadoop administration. So I have very good knowledge on Apache Hadoop administration. I set up this Apache Hadoop on virtualizations. I worked virtualizations softwares. Most of the times I worked on VMware, VMware, and on-premise. On-premise also we used virtualization. And next I worked on AWS cloud. We set up our cluster in AWS cloud, and also I have experience on with this Hadoop administration. I have experience on vendor Cloudera and Apache Hadoop plus Mapper. I didn't work on Hortonworks. Hortonworks also similar. So now Hortonworks is merged with the Cloudera. So there is no separate Hortonworks. You see only Cloudera. So most of the Hadoop market captured by Cloudera only. Some people using Mapper. So if you understand Cloudera, other vendors is nothing. First, if you understand Apache Hadoop, any vendor is nothing, because on top of Hadoop, Apache Hadoop only others vendors created, right? So first, this knowledge is important. Apache Hadoop administration is important. If you understand Apache Hadoop administration, learning other vendors is nothing. Okay, so I am offering like courses like later. I am offering Hadoop development, and NoSQL development, and I am handling Kafka development. As part of Kafka development, I am giving Kafka admin knowledge. So I cover around 30% of Kafka admin knowledge. Kafka admin knowledge. Okay. Next, I am covering Spark and Scala development. So these are my training. So it's not mandate. Based on your requirement, you can join in any other. Okay, my mobile number is, you can send emails regarding any technical or anything to this mail ID, masadoop@gmail.com, and you can call me on this number, 888-518-2309. This is, sorry, instead of this one, call on this number 89199 Okay, you can contact on this number. Any technical related or anything, you can send email to this mail ID. So tomorrow we freshly start our Apache Hadoop administration part. Okay, so instead of starting 5 minutes and stopping here, if any new people, intimate your friends. If any of your friends interested, intimate them, so that they will get a gain, because it's completely free. If they, it will helps them. Why I am offering for this one is, I am very much interested to about this Hadoop, because I'll say 2 minutes. I'll say why I like this Hadoop. So before this Hadoop development, I am a Java developer. Once I started learning Hadoop development, I thrown all my Hadoop materials and Hadoop documents, everything, books, in garbage. But still, Java is not leaving me, because I am working as a big data developer. So big data developer means, finally, uh, once we store data, once we process data, that data has to use by someone, right? That someone, middleware, right? Java applications. Okay, so still, I'm working with Hadoop and Spark with Java. Okay, so that's it for today. Tomorrow we freshly start from what is big data, what is big data. So we discuss all these concepts. I will share this syllabus and everyday notes to your email ID. Okay, so if you not get any material, please send your test mail to this mail ID. If you not get any email, please send me test mail to this mail ID, so that I will forward this one. I will create separate drive link. I will keep all these documents in that drive link. I will give permission to access that drive. Okay. Yep. Tomorrow same time. Tomorrow we have 7 o'clock, 7 to 8. It's fixed time, Jayasankar. Okay. Thanks for attending this workshop. We will continue tomorrow. If any one of your friends interested, please let them to join this workshop. Okay. Thank you. We'll meet tomorrow. Yep. Do you have any questions on today's topic, or if you want to get any additional information? Yep. I sent. I think whatever registration. Today we have a continuation. All today I started both Hadoop, Kafka, and Java. I already sent a link. I think go to that link, and did you if you registered, you can directly log into that one. No need, no need, Chandra. So tomorrow class we'll get in Hadoop architecture. I'll give you a clear idea, Chandra. Yep. Thank you. We'll meet tomorrow. Yep. In previous class, we discussed about what we are going to cover as part of Apache admin, right? As part of Apache Hadoop admin. So this course will help you a lot in your Hadoop development and Hadoop administration, Spark development. Okay, it's very important. So we are going to discuss all these concepts. This is very important for every developer, every Hadoop developer and Hadoop administrator, and any big data framework developer. Okay. So first, as part of this one, let's start Hadoop. So first, we are going to discuss what is Hadoop. Everyone knows Hadoop, but it's better to know what is Hadoop. Anyone having any idea about what is Hadoop? So it is a big data framework, right? It is a big data framework. Big data framework. What is big data? What is big data? So we are hearing the term big data, big data. What is big data? So big data means it is a huge volume of data, huge volume of data, volume of data which cannot be stored, which cannot be stored and processed, processed using traditional technologies, traditional technologies, technologies like RDBMS and application programmings within given time, within given time means short time. So within short time, if you want to process huge volumes of data by using RDBMS and application programmings, it's not possible. Okay. So to resolve this big data issues, we have Hadoop. So first problems with the big data is big data. First one, storage. Storage. There is no technology. There is no technology which can store which can store unlimited data, which can store unlimited data. And next one, processing. There is no technology, there is no technology which can process within given time, which can process within given time, within given time. So these are two problems. So to resolve this problem, we have Hadoop. Hadoop introduced to resolve above problems. To resolve storage, and processing. So HDFS is a file system which can store unlimited data, which can store unlimited data. First important point, HDFS file system can store unlimited data. And next one, MapReduce. MapReduce is a parallel processing system, is a parallel processing system, processing framework. It can process what? Data parallelly. It can process data parallelly. So that we get response very faster. So that we get response very faster. Not only MapReduce, based on MapReduce, there are some other algorithms are implemented by Hadoop framework. So those other frameworks or ecosystems process your data faster with a simple and easy implementation. Okay. So very important one, why people are going for Hadoop? That is very important. So that we understand, uh, so that we understand why people are going for Hadoop system. So first important one, let's understand what are Hadoop features. What are Hadoop features? Why people are going for Hadoop? First important feature is cost effective. First important feature, cost effective. Cost effective. So instead of Hadoop, if you go for RDBMS for your storage, RDBMS. In RDBMS, assume we are taking the popular database Oracle. Oracle is a licensed. Oracle is a licensed. Every year we have to renewal. Every year we have to renewal. Every year we have to renewal. This is first important point. Next, Oracle requires specialized hardware. Specialized hardware. It cannot run 24/7 in normal hardwares, because if hardware fails, it's take too much time to start your Oracle servers. It's not that much easy. To start Oracle cluster will take longer time. Not only Oracle, any RDBMS servers will take longer time to start, because complete data is resides in RDBMS system, right? So it requires specialized hardware. Hardware cost is high. Hardware cost is high. Coming to Hadoop, Hadoop is open source, and it is free. It is free. No license cost. No license cost. No license cost. First important feature is no license cost. If you go for RDBMS, every year we have to renewal. It's in crores, not like normal softwares. It is in crores and requires specialized hardware. But here Hadoop works on Hadoop works on commodity hardware. Commodity hardware. Hadoop works on commodity hardware, means normal hardware. So commodity hardware means it's a PC less than commodity hardware, commodity less than server hardware. Okay, so around 20 times it's less than server hardware. Approximately, I'm saying assumption, its cost is compared to server hardware very low. Server hardware is cost is very high. So that's what, if you go for Oracle and if you go for some other IBM DB2 kind of data storages, they give us some certified hardwares. So if you install these databases on that certified hardware, they give reliability. Means that hardware gives reliability. But commodity hardware and normal hardware cannot give reliability. So failures are, compared to server hardware, commodity hardware failure is high. But how it resolves this failures we see. Okay, so it's very important. So first important feature, we don't have a license cost. License cost is free. No need to pay single rupee for software. And next one, hardware cost is, it works on normal hardware, so hardware cost also very less. Next important feature is large cluster of nodes. Large cluster of nodes. Large cluster of nodes. If you go for the popular RDBMS, if you go for RDBMS, so Oracle cluster size, maximum, max 256 missions, 256 missions in a cluster. If you go warehousing databases like Teradata, Vertica, HP Vertica, and if you go for Netezza, they have a limitation maximum 512 missions, 512 missions in a cluster. So RDBMS has a limitation. RDBMS has a limitation. RDBMS has a limitation, but Hadoop doesn't have limitation. Hadoop does not have limitation. Does not have a limitation. We can take n number of missions. We can take n number of missions. N number of missions in a cluster. in a cluster. There is no limitation. We can take n number of missions in a cluster. So it's a very good advantage. So that only it providing unlimited storage. So because of this reason, so Hadoop supports what? Hadoop supports large cluster, and it offers more computing power because we are taking multiple missions, right? And huge volumes of storage Yes or no? Because of it supporting large cluster, it provides more computing power and huge volumes of storage. This is very important feature of Hadoop. Next, very important feature, parallel processing. Very important feature of Hadoop cluster is parallel, not Hadoop cluster, Hadoop parallel processing. Hadoop process data parallelly. Hadoop process data parallelly. Hadoop process data parallelly. So we have MapReduce framework, which can process data parallelly. How it process data parallelly? Can anyone tell me how it process data parallelly? Friends, how it process data parallelly? No. Jayashankar saying local, no. Different core. Yours good. And gathers results. Blocks, okay. Multiple slaves, okay. So some are saying divide data into blocks, super. So first we have to understand, very important is, because of HDFS file system, right? Your data is split into multiple blocks and placed into different missions. So we are, let me draw the diagram so that everyone in same page. So this is our Hadoop cluster. Assume we have a 5 node mission. 5 node mission. So user wants to store some file. Maybe assume we are taking 300 MB file. User wants to store 300 MB file. So first client approaches master mission. So this is master. So currently we don't know what is master mission process name. We will discuss master mission process name. These are slave missions. So master mission prepares metadata by dividing this file into multiple blocks. So note, from Hadoop 2.x, block size is block size is 128 MB. 128 MB. So 300 by 128 equal to 3 blocks. Okay, 128 MB by 3 we get 3 blocks. So here it prepares a plan how to place that file into, how to place that one into this Hadoop cluster. Then here assume block 1 is placed here, block 2 is placed here, block 3 is placed here. So whenever you run processing algorithm, it process your data parallelly because your processing algorithm instantiated in 3 locations. Your processing algorithm instantiated in 3 locations, your data process parallelly. So this is very important feature. So data may be any size, data may be any size, response is same, response is same. That is, it process very faster, it process very faster. How it process very faster? Just now we discussed, because of large cluster, we have more computing power. Yes or no? Because of large cluster, we have a more computing power. So it process very faster. So your data is processed very faster. So this is very, very important feature of Hadoop. Next one, and very, very, very important feature. Every feature is very, very important. So whatever the feature we are discussing, every feature is very important. So distributed data. Distributed data. This is very important feature of Hadoop. Distributed data. What is this distributed data? Just now we discussed, if you place data into Hadoop cluster, your data is split into multiple blocks and placed into different machines. Okay. Data is not stored in a single machine, not stored in a single machine, like existed architectures, like existed architectures, existed architecture. Data is not stored in a single machine like existed architecture. Data is split into multiple blocks. Data is splits into multiple chunks called blocks, and placed into or uh, or and stored in are placed or stored in different machines across the cluster. Different missions, in a cluster. You are getting right, team? So your data is not placed in a single machine. Your data is split into multiple blocks and spans across the clusters, are distributed across the clusters. Stores or distributes across the clusters. Are you understanding right? Okay. So next, very, 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 very important feature. So every feature is very, 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 very important. This feature is very, very, very important feature. Automatic failover. Automatic failover. Automatic failover management. You cannot see this feature in existed architectures. What we do as a administrator, we have to take care. So one of our friend question is, what if cluster is huge and data size is less? In that case, we will not go for Hadoop, right, friend? If data size is less, first of all, we cannot buy cluster. We cannot create huge volumes of cluster. Yes or no? So we are going Hadoop means our business having huge volumes of data. First of all, Hadoop is free. So whether your data is small or big, Hadoop is free. Software side, we discussed a cost effective feature. And second important feature, we spend less amount for commodity hardware, not like specialized hardware. So one more advantage in previous class I told, you can add any number of missions, you can remove any number of missions at runtime without stopping, without putting your Hadoop cluster in maintenance mode. Then why do we create a large cluster when we have a small data? We create only small cluster, right? If your data grows, then we increase cluster size, and we don't have a issue to add any number of missions at runtime. So we have lot of features, friend. Okay. So automatic failover management. See, we have a concept called replication, replication, replication. By default, by default, by default, Hadoop maintains three copies, three copies of each block, three copies of each block. By default, Hadoop maintains three copies of each block. Right? So by default, it maintains three copies of each block. So file one size is file one size is 300 MB. 300 MB. So if you split 300 MB by 128 MB, we get how many blocks? Three blocks. Three blocks. Yes or no? Each block replicated three times. So finally, your cluster contain 9 blocks. So if you lose one block of one block, you can read data from another block. So assume it is maintaining this block three places. Block 1 maintains in block 1 has three blocks. So one in this mission, two maybe in other missions. So we have to remember one important point. So we have a three blocks, right? For file, we have a three blocks. Each block replicated three times in Hadoop cluster. If one mission is down, we can access data from other missions. It is configurable. This replication is configurable. This replication is configurable. Configurable. As an administrator, as a Hadoop administrator, based on our hardware, we configure this parameter. As a Hadoop administrator, based on our Hadoop hardware, we configure this replication factor. See, your hardware is commodity hardware, so chances is failure is high. Then we configure 3. Your hardware is less than commodity hardware capacity, means normal hardware you are using. Hadoop will support normal hardware also. It can support any hardware. It is not strict to particular hardware. 1 minute. It is not strict to particular hardware. Okay. So you created Hadoop cluster with normal hardware. So you are thinking your hardware failures are high. You are thinking hardware failures may high. Then instead of 3 copies, you want to make it as 5 copies. You want to make it as 5 copies. Then you can configure that parameter in replication parameter in one of the configuration file. In our installation time, I will explain what are different configuration files are available, how to configure. So this Apache Hadoop administration is, we are not discussing brief, we are discussing in depth. Once you this course is completed, you will get very good knowledge of Hadoop. I will give 100% guarantee. After completing this course, you will feel. So my one important request, I have one channel, C Family Computers. C Family Computers is my website. So here I am updating new batches, and I have one more YouTube channel. So this is my YouTube channel. So here you will see different playlist. So we have different videos here. If you get chance, please subscribe our channel, and please share this channel information to your friends, so that I will get more subscribers to this channel. Okay, currently I have less users in this channel, so I have only 3000 plus users. So if you share this channel information, it will helps to your friends, as well as if I record any new topics, I will upload in this channel. You also get new updates related to Hadoop, or related to Spark, related to anything. Most of the times, big data, Java related, and real-time tools related, I'm uploading in this channel. So you also get notified, and you, if it is useful for you, you can go and view that videos. So my request is, if please subscribe this channel, and please share this channel information to your friends, so that they will subscribe. I will get more subscribers. It will help me. Okay. Yep. Let's continue. So we have different configuration files. In one of the configuration file, we will do this. We will increase or decrease replication factor size. Okay. Yep. Yep. Next, very important feature. Yeah, we didn't discuss, right? So we didn't discuss automatic failover management continuation in Hadoop. What this will do, if any system is failure, if any system is failure in Hadoop cluster, assume this machine is failure. but whatever the blocks presented in this machine have a replication in other machines, right? We can access our data from other machines. We can access data from other machines. Okay. So next very important feature is data locality optimization. This is very important feature, friends. Data locality optimization. Data locality optimization. What is this data locality optimization? What is this data locality optimization? See, coming to existed architecture like three-tier architecture. Let's say three-tier architecture. Three-tier architecture. So in three-tier architecture, we have user interface, and middle layer, and next we have database, database layer. So this we call presentation layer. We call it as presentation layer, and this one we call it as a business layer, business processing layer, or middleware, and this one is storage layer, persistence layer, persistence layer. So in three-tier architecture, we have different layers. This is one user interface. So here, user requested some data. This user requested some data. Assume sales data you want. Sales data of Hyderabad city. Sales data of Hyderabad city. Then this request goes to middle layer. This middle layer communicates with database layer, prepares this query, prepares this Hyderabad city related query, and sends this request to presentation layer. Presentation layer may be any database, maybe a Oracle database, maybe MySQL database, maybe DB2 database, any database. So this one sends this sales data back to this middle layer. Assume we have a 10 GB data. Assume we have 10 GB data here. 10 GB sales data. 10 GB sales data. On this 10 GB sales data, this 10 GB sales data comes here. Here we are applying on this 10 GB data. We are applying business logic. We are applying what? Business logic. Then finally, result, after applying business logic, we get some result, right? That result we are sending back to user interface. This result may be very small. So on this 10 GB data, we are applying processing logic. Then we are returning result to the user. Can you guess what is the size of this business logic application? Most of the times MB, right? Most of the times, even if you write thousands of lines of Java code or .NET code or other programming language code, if you write thousands of lines also, it is less than MBs only. Max MB. Yes or no? Right? Maximum MB sizes. But you, instead of loading these programs in data location, what we are doing, we are loading data into application location, we are applying processing, and we are returning to result. But in our Hadoop cluster, what will happen, in Hadoop cluster, we have a data in different locations. We have a data in different locations. We have a data in different locations. Assume we have a data in this format. We have a data in this format. Our client wants to sales data. Client wants sales data. Sales data of Hyderabad city. Sales data of Hyderabad city. So there is one more master. There is one more master called job tracker or resource manager in Hadoop cluster. This will taken care of taking read processing request. And what this master do is, this processing request is instantiated. Processing request logic is instantiated in different missions. Data is not moving to application location. Our application is moving to data location and process your data parallelly. Data may be 3 MB, data may be 10 GB, data may be TB, data may be petabytes, data may be zettabytes, exabytes. Your application is going to data location, not data is coming to application location. This concept is called data locality optimization. So this concept uh, gives what? Parallel processing. So you are understanding, right? So data locality optimization means application instances are created in data location data location and process data parallelly. Process data parallelly. Process data parallelly. So that we are reducing what? Network bandwidth. So if you observe, database servers may be resides in different locations, right? Database server may be different location, application server may be different location. So to transfer this data from application location to data location, data location to application location, it require more bandwidth, right? More bandwidth. And it is burden on a single mission to process this data. Yes or no? But in our Hadoop, application instance is created in data locations. So if your data has multiple data is located in multiple missions, your application instances created in every mission in data presented missions, then process your data parallelly, then result is going to save. Okay. Next, very important feature. So if you start discussing each feature of Hadoop, every feature of Hadoop is very important. That's why Hadoop is very important. Hadoop is popular because of these features only. One important point I'm notifying you is why is Hadoop is new architecture. People are thinking, is Hadoop is new architecture? No, it is not new architecture. It resolves existed architecture problems in new way. You are understanding, right? It resolving problems of existed architectures in new way. One, your data is distributed across the cluster and your processing is your application processing logics are created in data locations and process your data parallelly. So it is it is not a new architecture. It is same as existed architecture, but resolving existed architecture problems in new way. So if you are a Hadoop developer or if you are a Hadoop administrator, you cannot feel it's a new architecture. So you are a other administrator, means assume you are a database administrator, or you are a Linux administrator, or you are a other software administrator. Learning Hadoop administration is nothing, because you already done all the tasks earlier in another softwares. And moreover, this Hadoop reduces administrator responsibilities. Administrator is mandatory. Hadoop administrator is mandatory, but it reducing your tasks. Most of the times internally it performs automatic failover management, right? These kind of features, lot of features are available in Hadoop, so that it reduces administration burdens on administrators. Whatever existed softwares having problems, it resolves that problems, so that it reduces administrator uh, roles. Okay, so coming to this seventh important point, heterogeneous heterogeneous cluster. Heterogeneous cluster. What is this heterogeneous cluster? So most of the people think that no one using MapReduce nowadays. So why do we want to learn Hadoop? But finally, we are forgetting one important feature. We need we need a data store which can store huge volumes of data. Without data, how you can process your data? There is no way. And that too, it has to support parallel processing. Yes or no? First, data store must support huge volumes of data or unlimited data, and it has to support parallelism. Then only we can write a parallel processing applications. So without storage, we cannot think about processing. So without data, what is the use of processing logic? So data store is important. Hadoop is important. Hadoop is very, very important. On that data, you can do anything. Right? So Hadoop is very important. So on that Hadoop, people are using Sparks, people are using machine learning, people are using AI, people are using IoTs, people are using data science algorithms on top of data. So data store is very important, and there is no other competitor for our Hadoop, because Hadoop is free. Who will offer less than free? No one, right? If you give completely free, and that to open source, Apache giving complete source code of Hadoop. If you want to customize, you can customize your own way. We have all facilities, and this is not from normal vendor, normal distributor. It is from Apache friendly community. AFC, Apache Friends Community. Okay, so lot of features are there. That's why people using Hadoop. With Hadoop, any processing will help. So development means with Hadoop, we need other processing algorithms. But Hadoop administrator, this Apache Hadoop administration plus any other vendor Hadoop administration is important. Okay, let's discuss about heterogeneous cluster. Let me save this diagram. Heterogeneous cluster. I have a masters. I have master missions and I have slave missions. I have slave missions. I have slave missions. Let me take only one master instead of taking multiple masters. Master mission. I taken Sun Solaris operating system. Sun Solaris operating system and Sun hardware. So now it is Oracle. So this both operating system Solaris and Sun hardware is now it is from Oracle. For master mission, I used Sun Solaris operating system and Sun hardware. First slave mission, I used IBM AIX operating system and I used IBM hardware. For this mission, I used HP UX operating system, Unix operating system, and HP hardware. For this system, I used Red Hat Linux, and I used Intel hardware. For this system, I used CentOS operating system and AMD hardware. You are getting right? So it is not mandatory to take all missions operating systems are same, all missions hardwares are same. In Hadoop cluster, you can take any operating system and any hardware. Okay, so you can take any operating system and any hardware for different missions in Hadoop cluster. It's supporting. You can take any hardware, any operating system. It is not mandatory. It is not mandatory to take all missions in a cluster with same operating system and same hardware. But if you go for Oracle kind of databases, they will give certified hardware, certified operating system. If you take this operating system, if you take this hardware, then your Hadoop your cluster will reliable. If you go for SAP, they give us certified hardware and certified operating system. So if you want to install SAP, you need to use this operating system, you need to use this hardware. But we don't have such kind of restrictions in our Hadoop. You can take anything. Even for different missions, you can take different operating systems, different hardwares. You are getting right? So next, very important feature, scalability. So don't think we need scale to scale Hadoop cluster. We need Natra scale to scale Hadoop cluster, right? Scalability means, can anyone tell me what is scalability? Yep, horizontal. Okay. Any other? Capacity increase. Superb. Any other? Capacity decrease. Scalability, we can increase, right? Any size. Yes, you are almost all are you correct, but not decreasing, increasing. We can add any number of missions to cluster. We can add any number of missions to cluster. Unlimited storage. To achieve unlimited storage, we can add n number of missions, right? So scalability is very important. Yep. You also, someone says decreasing. Yes, that is scalability. We can increase or decrease. So another important scalability means we can add or remove any number of missions to cluster. We can add, remove any number of missions to cluster. Main advantage is here. Compared to other systems, compared to other systems, no need to stop cluster, and no need to put Hadoop in maintenance mode. Hadoop in maintenance mode, like other systems, means RDBMS, like RDBMS. We can add n number of missions. We can add n number of missions to Hadoop cluster. Without putting Hadoop cluster in maintenance mode, we can add, remove Hadoop cluster. Practically, we see this in our fully distribution mode. We will add some missions to existed cluster, and we can stop some missions to existed cluster. How your data going to arrange in Hadoop cluster? We see this practically. I will show this feature practically so that you will get a clear understanding. You will feel okay. So that's it for today. Tomorrow we are going to see Hadoop architecture. If any of your friends wants to learn this Apache Hadoop administration, let them to join in tomorrow class. Okay. So that's it for today. If you have any queries, you can ask me. Otherwise, we will continue tomorrow. Yep, we can create security also, Chandra. We have a security systems. We can create security. Yep, I'll tell some algorithms, different security algorithms later. But as part of our course, we are not discussing security here. So I will create separate course for Cloudera. Okay. In that Cloudera administration, I will cover security, how to implement security. So security is very important. You are correct, Chandra. So security is very, very important concern. So how to add updates, how to provide security for your data. So first level security, I said ACL, access control list, user management and group management. There we provide first level security, Chandra. Next level, we provide data level security. We will discuss it in one of the vendor, Cloudera administration. I will create that after completing our Apache Hadoop. I will schedule Cloudera around 30 hours class. 30 hours, not like 10 hours. 30 hours, just a minimal fee, not for only for I need anyone cloud system to explain that one, because minimum Cloudera requires 8 GB RAM. Okay. So I will plan Cloudera administration with the 30 hours. Then you can learn from that Cloudera administration. I will show you different security systems in that classes. Okay. Yep. That's it for today. We'll meet tomorrow. Yep. SSD is a drive type. So hard disk drive type. SSDs are very faster. Data data input output, right? That input output operations are very faster. But if you go for Spark kind of application processing, we are not going to process in SSD drives. Everything is presented in memory. So processing happen in memory. In that case, whether you have SSD or not, no matter. Processing happen in memories. Okay. Can you please send your email IDs? Just text me to this email ID, masadup@gmail.com. I will forward these documents to you. So I'm expecting all of you send your email IDs to this email ID. Okay. Yep. Thank you. We'll meet tomorrow. Yep. Today we see Hadoop architecture. So first we have to remember one important point is Hadoop follows master slave architecture. Master slave architecture. Master slave architecture. In master slave architecture, some missions act as masters and some missions act as slave missions, right? So in master slave architecture, master slave architecture, some missions act as master and some missions act as slave missions. So this is master mission and these are slave missions, slaves. Yes or no? So here problem is we have only one single master. Yes or no? If this master is failed, we lost uh, communication. Communication. So master receives all requests. Master receives all requests. So to resolve this problem, we have same architecture only, master slave, but here we take another master. So this one we call first master, we call as active master, active active master, and second one we call it as passive master, passive master. So if active master receives a request, if any request comes, active master receives a request. In this existed architecture, what will happen? Active master is responsible to receive request. If active master goes down, if any problem occurred in active master mission, maybe network issue, maybe power issue, maybe hardware issue, maybe operating system issue, any other issue, if active master goes down, passive master become active master. Passive master become active master, active master, passive master become active master. Then this active master now starts receiving requests from clients. Active, this is responsible to receive requests from clients. So this is existed architecture. So this is existed architecture. Same as this existed architecture, Hadoop also follows master slave architecture. Hadoop also follows master slave architecture. In Hadoop architecture, in Hadoop architecture, in Hadoop architecture, there are five daemons. There are five daemons. There are five daemons. One, name node, name node, and two, data node, data node, and three, secondary name node, secondary name node, secondary name node. Four, job tracker. So this is until until Hadoop 1.x, Hadoop 1.x, or resource manager, resource manager from 2.x from Hadoop 2.x Hadoop 2.x from Hadoop 2.x resource manager is responsible resource manager is introduced and job tracker is deprecated. And fifth one, task tracker until Hadoop 1.x node manager from Hadoop 2.x. So they replaced task tracker roles with node manager. So these are 5 demands involved in Hadoop architecture. Let's draw the diagram and understand Hadoop architecture. So first, it is highly recommended to start all master daemons in separate machines. It is highly recommended to start all master daemons in separate machines. Job tracker or resource manager. Name node. Next one, secondary name node. Secondary name node. And we can take n number of slave machines, n number of slave machines. So here we can take data node and task tracker or node manager. Task tracker or node manager. So in Hadoop architecture, some important notes I am writing. It is highly recommended. It is highly recommended to take each master daemon, each master daemon on separate machine, on separate separate machine, separate machine. So this is first important. So what are master daemons here? These are master daemons. Master daemons, masters. These are slaves. Slaves. Okay. So it is highly recommended to take master daemons on separate machine. Yep, correct. So one of our friend asking, what is daemon? What is daemon? So already we discussed daemon. Daemon is a process. Daemon is a process or program which always runs in which always always runs in background. Which always runs in background. So daemon is a process or program which always runs in background. So whenever we run our whenever we start our Hadoop system, Hadoop software, internally 5 processes runs in background. Okay. So it is recommended to highly recommended to take master daemons on separate machine. One more important point I am writing, until Hadoop 1.x, Hadoop 1.x, we can take only one only one name node, only one name node. So this architecture, so this architecture, this architecture is called this architecture is called single point of failure. Single point of failure. So if master node is failed, then we have to wait until master node boot. As a Hadoop administrator, we have to resolve the problem of name node. Then uh, we can then process will continue. This is the problem until Hadoop 1.x. But but from Hadoop 2.x, from Hadoop 2.x, but from Hadoop 2.x, Apache Apache introduced Apache introduced high availability, high availability, high availability called HA, high availability concept. From Hadoop 2.x, Apache introduced high availability. Then you can take multiple name nodes like previous architecture I explained, right? We have active master and passive master. Yes or no? Like that kind of architecture was introduced in Hadoop 2.x version. Before Hadoop 2.x, we have a single master name node. We can take only single master. If that single master is failed, we have to wait until that master boot or master starts. So to resolve that problem in Hadoop 2.x, they introduced high availability concept. You are getting right, team? Yep. So in Hadoop 2.x, we have a high availability concept. Next important point is, so it is recommended to take separate master missions on separate, right? So what are those? Name node, secondary name node, and job tracker or resource manager. These demands. Okay. Next important point, it is it is highly recommended, highly recommended, highly recommended to take both both data node, data node and task tracker or node manager, node manager on same mission, same mission. Data node, task tracker or node manager on same mission. Data node stores the data, task tracker process the data. So it is recommended to take both in same mission. So data location processing happen, right? So who will process the data? Task tracker or node manager. That's why it is recommended to take a data node and a task tracker task tracker on same machine. We will take based on our requirement, based on based on our uh, requirement, based on our requirement, we will take we will take multiple multiple slave missions. Slave missions. We take based on our requirement. We take multiple slave missions. Means your data is huge volumes of data. So we need unlimited storage, right? Yes or no? Your data is huge volumes of data. To store that huge volumes of data, to store that huge volumes of data, we take slave missions, multiple slave missions, data nodes. To process the data parallelly, we take multiple task trackers. That's why we start data node and task tracker in same mission. In same mission. Okay. Okay. So next, this architecture again divided into Hadoop architecture. Hadoop architecture again divided into two two types. One, HDFS architecture, HDFS architecture, and two, MapReduce architecture. MapReduce architecture. In HDFS architecture is responsible for responsible for storage. Storage. This MapReduce architecture is responsible for processing. Is responsible for processing. Processing. Okay. So here we have a daemons in HDFS architecture. Uh, we have daemons like name node, uh, data node, and secondary name node. But in processing we have first one, job tracker or resource manager, and task tracker or node manager. So processing, they introduced resource manager and node manager from 2.x version. Okay, let's see. So we have two architectures. We have two architectures. First one, HDFS architecture, HDFS architecture, and another one, MapReduce architecture. MapReduce architecture. MapReduce architecture. In HDFS architecture, we have name node and secondary name nodes as masters, and we can take multiple data nodes. Multiple data nodes. We can take multiple data nodes. name node and secondary name node, secondary name node, and multiple data nodes. Multiple data nodes. In this MapReduce architecture, we take master is job tracker or resource manager, and slaves are task tracker or node managers. So this one is job tracker or resource manager. Here we take task tracker or node manager. Task tracker or node manager. Task tracker or node manager. Okay. So these are master slave architecture. So this architecture is responsible for storage. This architecture is responsible for storage. This architecture is responsible for processing. Let's try. Someone asked a question. Oh, he raised. Uh, can you please send me your question in chat box? Yes. Each master node on different mission. Yes, Raghu. It is recommended. I am saying it is recommended, not mandatory. Recommended means you can take on different missions or you can take in a same mission. Depends upon your cluster. But recommended is, it is recommended to start separate mission. So only one thing, we start demands manually, Raghu. We have a commands to start name node, job tracker, all demands. We can start hyphen all is a command. It will start all demands in a single mission. If you want to start each demand separately, we have a command. If it is vendors, if it is vendor like Cloudera, they provide Cloudera manager. By using that Cloudera manager, Cloudera manager is a web interface. There you can start each demand separately on each mission. Yeah, Balu, if possible, can you write a message here? Yep. Arun asked one question. What happens if task tracker and data node uh, fail from a single mission? That's what we will take multiple. Yep. We take multiple slave data node missions. That's what our architecture. So data node and task trackers are, we run in same mission. So if one data node fails, we can access data from other data nodes. If it is a single mission, we cannot do anything, right? If we start all demands in a single mission, we cannot do anything. We have to resolve problem of mission, then we can use it. If it is a cluster, data is replicated. Data is replicated in multiple missions. Data is replicated in multiple missions. Okay. we are going to discuss that architecture, Arun. No worries. So we are just discussing what is HDFS architecture, what are demands involved in HDFS architecture, what is MapReduce architecture, what are the demands involved in MapReduce architecture, what is the role of HDFS architecture demands, what is the role of MapReduce architecture demands. Then we are going to discuss if there is any problem occurred in a single mission, then what will happen? We are going to discuss as part of complete practical part.
Yeah, hello.
Yes, Balu.
Yeah, hope Akhil has attended the session, right? Akhil is a new student.
Yeah, yep.
Yeah, please record the session. I hope this is the demo class, right? Please record the session and send to Akhil, please. Okay?
Yep, sure, Balu.
Sure. Thank you. Thank you, sir. Thank you.
Thank you. Thank you. Yep.
Yeah. Bye.
Bye. Yep. Okay. So HDFS architecture for storage and MapReduce architecture is responsible for processing. Okay. So here, mm, yep. So these architecture receives storage request. This architecture receives storage request. Storage request. This architecture receives processing request. Processing request. So you are getting right. Name node receives storage request, and job tracker or resource manager receives processing request. Okay, let me save this one. Let me give Hadoop cluster architecture. Hadoop cluster architecture. Hadoop cluster architecture. So what is cluster, friends? Any idea? Most of them know about this cluster. Uh, can anyone tell me what is cluster? Hello, team. Yep. Multiple nodes in a multiple nodes. Okay. Group of missions. Yes, correct. Any other? Passive active mode. Okay. Group of missions connected through network. Distributed. Okay. So you all are correct. Whatever you said is 100% correct. Yep. Group of missions of same application in passive active node mode. Okay. Yep. So simple terminology. Cluster is a collection of missions or group of missions. Cluster is a collection of missions or group of missions. Group of missions. So simple terminology. Cluster is a collection of missions or group of missions. So whatever you said is correct. Okay. Next important point here is see in general Hadoop cluster we have data centers. Data centers. Data center. Can anyone tell me what is data center? If you have an idea. Data center. What is data center? A data center is a geographical location. A data center, a data center is a geographical location. Any location. Any location we call it as any geographical location we call it as data center or region. Region. Yes, you are correct. Right. So we will take multiple data centers, and in data center we create racks. In data center we create racks. In data center we create racks. So this is rack 1, rack 1, rack 2, rack 3. Like this we take multiple racks. Okay. So what is rack? A rack, a rack is a collection of a rack is a collection of machines. A rack is a collection of machines. So in a rack we take multiple machines. In a rack we take multiple machines. In a rack we can take multiple machines. So we take multiple machines in a rack. How each machine communicates with other machines in a rack? How each machine communicates with other machines in a rack? For this one, we take one switch. We take one switch. So switch. So we connect all these machines to this switch. We connect all these machines to switch. So that all machines communicate with each other. Through the switch, all machines communicate with each other. Okay. So in this way, communication is happen. Communication is happen. Okay. So we take data center. In data center, we take multiple racks. Each machine communicates with other machine through the switch. So like this, we take depends upon our requirement. We take multiple data centers. Multiple data centers. Data center 1, data center 2, data center 3. Like this, we take multiple data centers. So this is data center 1, data center 2, data center 3. So like this, we take multiple data centers. How each data center communicate with other data center? How each data center communicate with other data center? So we take main switch. So we connect all these machines to main switch. So this switch is connected to through the network. This switch is connected to this machine. This switch is connected to main switch. This switch is connected to main switch. So if this machine wants to communicate with this machine through this switch, uh, signals are passed through this switch, and this switch to this machine. So in this way, one data center mission from one rack to communicate with other data center with other rack mission. Okay, in this way communication is happen. Okay, so we may take name node here. We may take secondary name node here. We may take job tracker or resource manager here. Job tracker or resource manager here. And I'm taking remaining are data node and task tracker or node manager. Remaining missions I'm taking in this way. This is fully distributed mode, friends. In fully distributed mode, we take cluster in this way. Okay, so here yeah, we can set up for disaster recovery. We take multiple data centers. So Chandra is asking, is this disaster recovery? So why we create multiple data centers means to resolve disaster recovery. See, one data center may fail, right? So we can access data from other data centers. Yes or no? That's why they take different data centers in different regions. Region means different geographical location. Okay. So here there is one important point here is there is one special concept called proximity algorithm. Proximity algorithm. In proximity algorithm, we will specify data center name, data center details. In proximity algorithm, we will specify data center details, rack details, missions details, network bandwidth details, network bandwidth details. So we provide complete all details in proximity algorithm. So this is very important in Hadoop cluster. So in proximity algorithm, we will provide information of data center, and we provide information of rack details, and we provide information of each mission. Sorry. Yep. Sorry. Mission details and network details. Yep. We provide these complete details so that whenever you store data, master mission first reads this proximity algorithm and identifies where is data center, where is rack, where is missions, and what is the bandwidth of each mission. It finds this complete information from this proximity algorithm. Then based on these details, it will store blocks into corresponding missions. So it will, I said, name node, master mission reads data, receives storage request, and prepares metadata, right? Then allocates, prepares metadata. In that metadata, it will provide information of where blocks are going to store. So it prepares that information by using this proximity algorithm. Okay. So let me save this one. What is HDFS file system? What is HDFS file system? What is HDFS file system? How data stores in HDFS file system? How data stores in HDFS file system? So can anyone tell me what is HDFS file system? What is HDFS file system? Any idea, team? Any idea what is HDFS file system? It's a distributed file system across multiple nodes. Okay. And another person said storage in Hadoop ecosystem. Okay. Any other? So coming to HDFS file system, we all are good at full form, right? Hadoop distributed file system. Yes or no? Hadoop distributed file system. Hadoop distributed file system. So HDFS file system means Hadoop distributed file system. Hadoop distributed file system. It is a user space file system. User space file system. What is the difference between difference between difference between uh, local file system and HDFS file system? HDFS file system. What is the difference between local file system and HDFS file system? For all these questions, I am writing answers here. So what is difference between HDFS file system and local file system? Just now I said HDFS file system is a user space file system. Local file system means operating system file system. Operating system file system. Operating system file system starts as part of operating system process. Operating system process. When operating system starts, right, it will start as a operating system process. So we cannot increase we cannot increase or we cannot decrease file system size. We cannot decrease and we cannot increase file system size. It starts as an operating system process, but local file system sizes local file system sizes local file system sizes file system block sizes 4 KB in old operating systems. In new operating systems it is 8 KB. In new operating systems it is 8 KB. So it starts as a operating system process. So we cannot increase or decrease file system size or file system block size. Coming to HDFS file system. HDFS file system is a user space file system. HDFS file system is a user space file system. It starts as a HDFS file system starts as a user process. You are getting right? Whenever operating system starts, file system starts. Local file system starts. But HDFS file system starts as a user process. Whenever we start Hadoop system, then only it will start, right? Who will start this Hadoop file system? After starting our operating system, Hadoop will start, right? That's why we are saying it is a user space file system. It starts as a user process. Okay. HDFS file system, HDFS file system, block size, block size, block size until Hadoop 2.x, Hadoop 1.x, until Hadoop 1.x it is 64 MB. From Hadoop 2.x, from Hadoop 2.x, block size is 128 MB. Default block size. This is default block size. From Hadoop 2.x, default block size is 128 MB. But we can configure. We can configure. We can configure. But we can configure. Means we can increase. We can increase or decrease block size. We can increase or decrease block size. So this is one of the advantage of HDFS file system. We can increase or decrease. So with multiples of 64 MB, with multiples of 64 MB, with multiples of 64 MB. Example 128 MB plus 64 MB plus 64 MB. Like this we can increase. You can increase or decrease with multiples of 64 MB. You are getting right? So HDFS file system is a user space file system. It starts as a user process. So the default block size of HDFS file system is 64 MB until 1.x, 128 MB from 2.x, but it is configurable with multiples of 64 MB. So I will tell how to configure this HDFS file system. If you not configure, then it will take it as 128 MB as a default in from Hadoop 2.x. Okay. So next to class, I will explain how we place, how or what will happen when you place file into HDFS file system. When you place file into HDFS file system, what will happen when you place file into HDFS file system? So tomorrow class we discuss this one in depth, so that you will understand how HDFS file is going to split into multiple blocks, how it plays each block into different machines. So it depends, right? So it is never by default. Everyone uses default block. If you want to increase readability, fast reading, then we increase block size. So at a time, earlier at a time, it reads 64 MB block. From Hadoop 2.x, it is reading 128 MB block at a time. So readability, seeking time or reading time become faster. So if you want to increase reading time, then you can increase 128 MB by 64 MB. So it will increase readability, but problem is data is not distributed, right? So for example, if you increase block size is 300 MB, so you place the file 300 MB file, so only one block. So one machine process this 300 MB block. So if you increase more size, but distribution is not happen. So in that case, it is recommended to take based on your requirement, based on your data size, we increase or decrease file system block size. Okay. So that's what clearly I'm saying. It is default block size. We can find this default block information in one of the configuration file properties. So they give us some configuration files. In that configuration files, you can find, you can Google that configuration file properties. It lists all the information of properties. Okay. So installation part, I will explain clearly what are different properties we configure as part of installation. So tomorrow also we discuss HDFS file system and these daemons discussion. Once you understand that HDFS file system and daemons details, then we start installation of Hadoop. Okay. So that's it for today. We will meet tomorrow and we'll continue HDFS file system. Okay. Yep. Yep. In previous class, we discussed uh, Hadoop architecture. Hadoop architecture. In Hadoop architecture, we discussed what are different components of Hadoop, what are different components components or demands of Hadoop, demands of Hadoop. Then we discussed HDFS architecture, and we discussed MapReduce architecture, MapReduce architecture, right? So today class, what we are going to do is, what is HDFS file system? What is HDFS? Yesterday we discussed this one also. What is HDFS file system? Yes or no? What is HDFS file system? Yesterday we discussed all these concepts. So today we'll discuss how to, what will happen, sorry, what will happen when client wants to place file, when client wants to place or store file into HDFS file system, file into HDFS file system, HDFS file system. So what will happen when client wants to place file into HDFS file system? So client 1 want to store file 1 with size to 300 MB. So client want to place file with the size 300 MB. Okay. So in HDFS file system, file system, file system, file is splitted into file is splits into what? Multiple chunks, right? Multiple chunks. File splits into multiple chunks called blocks. Called blocks. So the default block size, the default block size. Can anyone tell me what is default block size? Hello? Can anyone tell me what is default block size? Yep, superb. Yes, you are correct. So until Hadoop 1.x, Hadoop 1.x, block size is 64 MB. From Hadoop 2.x, from Hadoop 2.x, block size is 128 MB. 128 MB. Okay. Let me explain. When client want to place file, what will happen? Okay. So diagrammatically, I am explaining. So this is our file. Sorry, Hadoop cluster. So we have a master mission and multiple slave missions. Multiple slave missions. So we have 5 slave missions. We have 5 slave missions. As a Hadoop administrator, we have to get complete in-depth knowledge of this internal things, because we are going to deal with this background file system. If you want to modify, we do modifications. Everything configuration part is taken care by Hadoop administrator, not Hadoop developer. Hadoop developer knows about these things, but we cannot give access to modify anything on Hadoop cluster. We are means Hadoop administrators are responsible for everything. So we have to know these things very in depth. Team, are you getting my voice? Hello? Yep, maybe. Okay, this is our 5 node cluster, 5 slave missions and 1 master mission. So this is data node, sorry, name node, and these are data nodes. Data node 1, 2, 3, 4, and 5. So we have 5 data nodes. Okay, client want to place file. So this is client 1 mission. Client 1 mission. Client want to place file with the size what? 300 MB. File name is file 1 and size is 300 MB. 300 MB. File size is 300 MB. First client sends a request to name node. First client sends a request to name node. First client sends request to name node. Then name node prepares metadata. Name node prepares metadata. Name node prepares metadata. Name nodes prepares metadata. So before preparing this metadata, it will read hdfs-site.xml file. Name node reads hdfs-site.xml file for block size, comma, for replication factor, for replication factor. So for replication factor, it will read these two files. So for size, default is 128 MB. Default is 128 MB. Okay, default replication factor is 3. And next it reads slaves mission, slaves file for data nodes, and it reads proximity algorithm, it reads proximity algorithm for data centers, comma, racks, comma, bandwidth information. In yesterday architecture, I explained what is data center, what is rack, what is bandwidth means internet speed. Based on this information, it will prepare this metadata. 1 minute. Sorry. Okay. For this information, it will read these files, then prepares metadata. So metadata means mapping of file to block to data nodes list. 1 minute. Sorry. Data nodes list. So metadata contain mapping of file to block to data nodes list. So here it prepares metadata in this way. File 1, sorry, before that I'll explain. So block is divided in this manner, 300 MB by 128 MB. We will get 3 blocks. We get what? 3 blocks. Block 1 with 128 MB. Block 2 with 128 MB. Block 3 with 128 MB. So these are 3 different blocks. Okay. So in this way we get. Then here it prepares metadata saying file 1, block 1, data node 1, 3, 5. File 1, block 2, data node 2, 3, 5. File 1, block 3, 4, 5. In this way it prepares metadata. First block is placed 1, 3 and 5. So block 1 is placed here, and block 1 is placed here. one let's 1 minute. Someone asked a question. Yep. Akhil asking why it is 1 comma 3 comma 5 and 2 comma 3 comma 5. Yep. For that question, Akhil, so it reads proximity algorithm. In this proximity algorithm, it contains bandwidth of each mission and racks information and data center information. So here we created, right? This is our assumption. This is our assumption. Internally, it reads the slaves file and reads proximity algorithm based on client with the nearest location of data centers. It will prepare metadata. This is our assumption, Akhil. Internally, based on proximity algorithm, it will prepare what? Metadata. Okay. 1 minute. Someone calling. Okay. Yeah, you got it, Akhil. So this is our assumption. Okay. So block 2 is placed in 2, 3, and 5. So block 2, and block 2, and block 3 is placed. Block 3, block 3 is placed in 3, comma 4, comma 5. Block 3, block 3, block 3. So in this way, data is placed in Hadoop cluster. So this is Hadoop cluster. So client places data into in this manner. First, client interact with the name node. Name node prepares metadata based on these parameters and returns this information back to client. Then once a client get this metadata information, then client writes the data into hdfs file system. So if you understand here name node is not responsible to write data. Client is responsible to write data into Hadoop cluster. Just name node prepares metadata and returns this information back to client. Then once the client gets this metadata information, then client writes the data into hdfs file system. Okay. So here we have to know main important points. Block means it's a it is a small, it is a chunk of data. It is a chunk of data. It is a chunk of data. So here replication. What is replication, Tim? Just now we discussed. What is replication? Can anyone tell me what is replication? Multiple copies. Okay. Keeping same data in other servers. Okay. Same copy of other data. Superb. Okay. Any other? Yes, can you please start so that it become interactive session? Whatever you know, you can please chat. In real time, what is block size used in industry? So I said default block size. We go for default block size, Srinivas. It seems 128 MB is too high. No. So because of why, if it is 128 MB is high, then Apache cannot define size. It is big data file system. So to read data very faster, then they defined this 128 MB size. Duplicate copy of data. Yes, you are correct. So whatever your answer, always all of you correct. So it's a duplicate copy of same block. Duplicate copy of same block. So there is one more concept, replication factor. Replication factor. What is replication factor? Replication factor means how many duplicate copies. How many duplicate duplicate copies of duplicate copies of same data. Duplicate copies of same data is called replication factor. So the default replication factor is tell me, replication factor is 3. The default replication factor is 3. Yes, you all are correct. So it is configurable. It is configurable. Configurable. We can we can increase, we can increase or decrease this replication factor size based on our requirement. We can increase or decrease replication factor. Okay. So we have different demands in Hadoop cluster. So we saw in Hadoop architecture, we have different demands. So each demand has its own role. Its one role. So we have HDFS demands, we have MapReduce demands. HDFS demands are responsible for storage part. MapReduce demands are responsible for processing part. So HDFS demands. What are HDFS demands? Can anyone tell me? Can anyone tell me what are HDFS demands? Can you please type in chat box? Name node, secondary name node, data node. Okay, data node, name node, secondary name node, secondary name node. Superb. Yes. So HDFS demands are name node, name node, data node, and secondary name node, secondary name node, secondary name node. Next, secondary name node. Okay. Next one, MapReduce demands. MapReduce demands. What are MapReduce demands? Can anyone tell me? Transaction node. Okay. Job tracker, resource manager, task tracker, name node. Superb. Yes. Yes. Wow. So MapReduce demands are job tracker, job tracker, or resource manager, resource resource manager, and task tracker or node manager, node manager, task tracker or node manager. What is the responsibility of HDFS daemons? These are responsible for these are responsible for responsible for storage, storage. These are responsible for these are responsible for these are responsible for responsible for processing. These are responsible for processing. HDFS daemons are responsible for storage. MapReduce daemons are responsible for processing. Okay. So here, see, uh, next we are going to see Hadoop installation, Hadoop installation, Hadoop installation. So here, this Hadoop installation prerequisites, Hadoop installation prerequisites. So we need one, we need virtual machine, virtual, virtual, virtualization, virtualization software, because we are using Windows operating system. So instead of installing dual boot in Windows, install any virtualization software. So we have virtualization softwares like VMware, VMware workstation, workstation, comma, virtual box, virtual box, and we have other also, other. Uh, in our course, I am using VMware workstation, VMware workstation, VMware workstation. Next, we require any Linux, Linux operating system, any Linux operating system, any Linux operating system. We have two flavors, Debian, Debian flavor, Debian flavor, and Red Hat flavor, Red Hat flavor. So it won't give any smell like flowers. Flavor means smells, right? So Debian flavors like Debian, Debian, Ubuntu, Ubuntu, etc. Red Hat flavors like Red Hat, Red Hat, CentOS, CentOS, and Fedora, etc. Fedora, etc. There are multiple operating systems. So here I am going to use, in our example, I am going to use CentOS, CentOS. Okay. Third one, third one, Java, Java 1, Java 8, Java 8 or later versions, later. So we need Java 8 or later versions. Next one, we need network, we need SSL, sorry, SSH. So here we create passwordless passwordless SSH, passwordless SSH. Then we use some networking commands, uh, networking networking commands. So Linux networking commands. We are going to use Linux in networking commands. So we are going to learn all this. So if you try to install VMware workstation in your system, I will show you how to install Linux flavor, and I'm going to show you how to install CentOS, how to install Java, how to set up passwordless, why we are setting passwordless SSH, and what are different networking commands we are going to use as part of our Apache Hadoop administration. So it is complete practical part. Okay. Uh, Next class we are going to start this practical part. Okay. Let's start. In previous class, we discussed about prerequisites for installation, and before that we discussed HDFS concepts, right? We discussed HDFS concepts, and we discussed prerequisites for Apache Hadoop installation. Apache Hadoop installation, right? Today class, today class, uh, we are going to discuss types of Hadoop installation. Types of Apache Hadoop installation. Apache Hadoop installation. Okay. So we can install Hadoop in three ways. We can install Hadoop in three ways. They are: first one, local or standalone mode. Standalone mode. Local or standalone mode. Second one, pseudo distribution mode. Pseudo distribution mode. And third one, fully distribution mode. Fully distribution mode. We can install Hadoop in three ways. One is local or standalone mode, and second one pseudo distribution mode, and third one fully distribution mode. Okay, so let me explain all these three types. So I'm explaining these three diagrammatically. Okay, so local mode. Before going to explain local mode, first I'll explain how Hadoop installation. So first we need operating system. We need operating system. We need operating system. On top of operating system, we need to install JVM. We need to install JVM. What is JVM? Can anyone tell me what is JVM? Hello? Yes, it is a Java virtual machine. It is a Java virtual machine to run Java programs, right? To run Java programs. To run any Java program, we need Java virtual machine. So Hadoop is implemented by using Java. That's why to run Hadoop software, we need JVM. So finally, on top of JVM, we install Hadoop. We install Hadoop. So you can install Hadoop of Apache vendor, Hadoop of Cloudera vendor, or any vendor. Vendor may be Apache, vendor may be Cloudera, vendor may be any vendor. We need JVM. On top of JVM, we install Hadoop. So this is Hadoop. So let's discuss local mode. Local mode, local or standalone mode. Local or standalone mode. In local mode or standalone mode, all demands runs in on single JVM. All demands runs on single JVM. So same as this one, we have operating system and we have JVM. On top of JVM, remaining 5 demands, right? We have a name node, and secondary data node, secondary name node, job tracker or task tracker, and next one resource manager or node manager, right? So all demands name node, secondary name node, data node, and job tracker or task tracker and task tracker. Next one, either job tracker or resource manager, right? So here task tracker or node manager, right? So these all demands runs on a single JVM. These all demands runs on a single JVM in local mode. Okay. So this is single JVM. If you use pseudo distribution mode, in pseudo distribution mode, all demands runs on separate JVM. All demands runs on separate JVM. In pseudo distribution mode, all demands runs on separate JVM. So here, let's remove this one. So this one runs on separate JVM. 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 Okay. Yep. Let me draw this diagram and I'll clear your doubt. Okay. Yep. So here in local mode, in local mode, let me explain here. In local mode, all demands in local mode or standalone mode, all demands runs on single JVM, runs on single JVM. This is for development and debugging purpose. Debugging purpose. This is not for testing and production. This mode is not useful for testing and production. And coming to pseudo distribution mode, in pseudo distribution mode, pseudo distribution mode is for both. It runs on first. I didn't cover this one. We set up local mode or standalone mode on single mission. Single mission. All demands runs in a single mission. All demands runs in a single mission. Okay. So pseudo distribution mode, same as this one. Pseudo distribution mode also we set up in uh, single mission. Pseudo distribution mode we install on single mission, and all demands runs in a single mission. In pseudo distribution mode or local mode, all demands runs on separate JVM. All demands runs on separate JVM. It is for both development and debugging. Local mode is for both development and debugging, but this one is for both development and testing purpose, but not for production purpose. So this pseudo distribution is not suitable for production purpose. Each daemon is a separate program. That's why we can run on separate JVM. Okay. So in fully distribution mode, all daemons runs in separate JVM. All daemons runs on separate JVM and on separate machine. Fully distribution mode. In fully distribution mode, all daemons runs on separate JVM and on separate machine. So fully distribution mode we create in this way. Take a fully distribution mode. Fully distribution mode. So it is highly recommended to take master missions on separate JVM. Master missions on separate JVM. And we can take multiple slave missions. We can take multiple slave missions. So this is job tracker or resource manager. This one is name node, name node. This one is secondary name node. Here we can take data node and task tracker or data node and task tracker or node manager. Task tracker or node manager. Okay. So we can take task tracker or node manager. Task tracker or node manager. Task tracker or node manager. So in fully distribution mode, all demands runs on separate JVM on separate machine. It is highly recommended to take all master master daemons on separate mission separate mission separate mission. Okay. Next, it is highly recommended. It is highly recommended both uh, data node and task tracker or node manager on same mission. Okay. Because data and process demands must be on same mission. Okay. Depends upon our requirement. Depends on our uh, requirement or data size. Depends upon our requirement or data size. We take multiple slave missions. Okay. In fully distribution mode, depends upon our requirement, we take multiple slave missions. You are getting right, team? You are understanding right? These three types of installation. Okay. Now we are going to see installation part. One important note. By default, Hadoop installation is local mode. Hadoop installation is local mode. Local mode. By default, Hadoop installation is local mode. So when you download and install, then by default it is called local mode. Local mode or standalone mode. Okay. So we convert to local mode to pseudo distribution mode or fully distribution mode. We convert local mode to pseudo distribution mode or fully distribution mode. If you download and extract and set up class path, by default it is local mode. Then we convert that local mode to pseudo distribution mode or fully distribution mode. Okay. So first let's start with pseudo distribution mode installation. In pseudo distribution mode, I will tell you when we call local mode. Okay, pseudo distribution mode. In pseudo distribution mode, all daemons, runs on same mission, but different daemons, right? But on different JVM, but on different JVM. Yes or no? In pseudo distribution mode, all daemons runs on same mission, but on different JVM. How it runs on separate JVM, we will see. 1 minute. Okay. So pseudo distribution mode. All demands runs on same mission, but on different JVM. Okay. So here we have any installation. It may be local mode. It may be pseudo distribution mode. It may be fully distribution mode. We have 3 steps. Any Hadoop installation. Any Hadoop installation means local or pseudo or fully distributed mode. Fully distributed mode. Any Hadoop installation, it may be local or pseudo or fully distributed mode, has 3 steps. First one, step 1, pre-installation steps, and step 2, installation steps, and step 3, post-installation step. Post-installation. So we have pre-installation and installation and post-installation. We have 3 steps. Okay. Any Hadoop installation has 3 steps. One is pre-installation, and another one is installation. Next one is post-installation. Okay, let's see first pre-installation. So pre-installation, let me take first step one. In pre-installation, what we do? In pre-installation, what we do? Okay, in post-installation step, what we will do? And post-installation, what we will do? So first, installation, pre-installation, we need first operating system. We need operating system. So most of the times Linux. Most of the times Linux. Next one, Java installation. Java installation. So we need to install Java. Second one, dedicated user. Dedicated user. User. Instead of dedicated, let's say user. User is required. So in pre-installation step, we need operating system. Java must be installed on operating system, user, and the next one, passwordless passwordless SSH. Why passwordless SSH is required? I will explain. Okay. Next, these are very important before installing Hadoop. In installation step, in installation step, we download Hadoop tar file, Hadoop tar file. Next, extract tar file, extract tar file. Optionally rename, Next, set Hadoop underscore home, and path variable. Set Hadoop underscore home, path variable. Next, verify Hadoop, verify Hadoop, verify Hadoop. So these steps we do in installation part. In step 3, post installation. After installation, to convert from local or standalone mode to pseudo mode or fully distribution mode, fully distribution mode. So before that, I cover one important point here. In local mode or pseudo distribution mode, it uses local file system. It uses local file system. In pseudo mode or local mode or standalone mode, it uses local file system. In HDFS mode, pseudo distribution mode, it uses HDFS file system. It uses HDFS file system. So because we need distributed, right? Here for debugging purpose, distributed is not suitable. That's why it uses local file system. And fully distribution mode also uses fully distribution mode also uses HDFS file system. So what we do, so to convert from local to pseudo mode or fully distribution mode, first we do what? We will specify specify HDFS file system type. This is one. Okay. And one more, we do we do some modifications, some modifications or some configurations, some configurations in core hyphen site site.xml file. Next one, core site.xml file. Next one, hdfs site.xml file. hdfs site.xml file. Next one, mappred site.xml file. And next one, yarn site.xml file. Yarn site.xml file. Next, we do some modifications in slaves file. And next, masters file, files, etc. So these are some important configuration files. In post installation, we do all these steps. Then we start and stop stop daemons. We start and stop daemons. We verify daemons. We verify daemons. Okay. We will then we do our activities. Okay. We do all these steps after installation. That's why we are calling post installation steps. 1 minute. Yep. Let's go for pre-installation steps. Pre-installation steps. Okay. So first, to install operating system, we are discussing requirements. As part of operating system installation, I am going to install CentOS 7. Why I am installing CentOS 7 means it is uh, Red Hat flavor, Red Hat flavor, Red Hat flavor, and most of production servers are CentOS. So if you understand, if you get understand in if you get hands on CentOS, you can easily work on any Red Hat flavor operating system. Okay. Ubuntu is a Debian flavor. I already said Ubuntu is a Debian flavor. So most of the most of the people doesn't use Ubuntu for production purpose. So only most of production servers are Red Hat or Red Hat flavors. Few systems, few servers are Debian flavors. So it's my recommendation is install CentOS, get practice, and you can work on any Red Hat flavor. Why we are not installing Red Hat in our system means it's a licensed version. CentOS is completely free. Okay. So next, to install this operating system on our machine, we need virtualization software. Virtualization software. We need virtualization software. Here we can use VMware Workstation. We can use VMware Workstation or VirtualBox, etc. There are multiple softwares, but as part of our course, I am going to use VMware Workstation. VMware Workstation. Okay. Next, so these are requirements for VMware. So next, Java installation, we are going to use Java 8. Java 8 or later version is required. So recommended is Java 8. Java 8. So at the time of operating system, at the time of operating system, I will create user. Or after installation also we can create user. After installation also we can create user. But at the time of operating system, I will create user. Then I will explain what is the use of passwordless, how to create passwordless. So first, this one. So yeah, download VMware Workstation, and install. Download VMware Workstation and install. So here, go to Google. Search VMware Workstation download. This is authorized website link, and this is file hippo link. You can download from authorized website or from file hippo, anyone. You can download from authorized website or from file hippo. File hippo is also a trusted website. File Hippo also a trusted website. Okay. Once you download, and it will download exe file, double click on that exe file and follow steps. Most of the times choose default options. Don't change any options. Install virtual VMware workstation. Here search VMware. You will get VMware Workstation Pro, or desktop also you get icon saying VMware Workstation. Okay. Once you install successfully, next step B, install, download and install, download and install CentOS, CentOS latest version. So current current version is 7. Current version is 7. CentOS 7. Okay. So go to Google and search CentOS download. CentOS download. Here you will see first link. Go to first link. So here you will see download option. So we are seeing two options. One is DVD ISO, and another one is minimal ISO. DVD ISO contain a lot of third party softwares, but minimal ISO contains only operating system and supported files. Other softwares, other required softwares, we have to install manually. Recommended is minimal ISO. So most of the times we use minimal ISO, not DVD ISO. Whatever the software is required, we install those softwares manually. Yep, whatever you know, you can do it with operating systems. Okay. So most of the times we go for minimal ISO. First time I am downloading DVD ISO. Next later I will download minimal ISO and I will install this one. For DVD ISO, it requires minimum of 2 GB RAM. Minimum of 2 GB RAM. Okay. DVD ISO require minimum 2 GB RAM because it install graphical user interfaces. If it is a minimal ISO, everything is command prompt. It will work from 256 MB RAM. So it's recommended minimum 512 RAM, not 256. Minimum recommended 512 RAM for minimal ISO. I am not saying Hadoop. I am saying for minimal ISO. Okay. But for Hadoop requirement minimum 2 GB RAM. Apache Hadoop. Minimum it's recommended 2 GB RAM. Okay. So download and install CentOS. So let's see. Go to this DVD ISO. Click on this DVD ISO, and here you will see different links. Click on any one of the link. It is asking you to download, so you can download. It is 4.27 GB. It is 4.27 GB. Okay. I have already installed in my system. Then go to VMware workstation icon. Click on this VMware workstation icon. It will open VMware. In your system, you may not have all these installations. You may not have all these installations in your system. It is fresh installation, right? But in my machine already some operating systems are installed. Let me install our sudo distribution mode, Apache sudo distribution mode setup. For that one, we are installing operating system. So right click on here, click on new virtual machine. Right click on here, click on new virtual machine. So select all default options. So default, leave it as typical. Click on next. And if it is not selected, I will install operating system later. Select this one. If it is selected, okay. Click on next. Here it is showing different operating systems supported by VMware virtualization software. So here choose Linux. In this Linux, it is supporting many Linux operating systems. Here we are installing CentOS, right? Yes or no? So CentOS 7 64-bit. Okay. Then click on next. Here I am giving name is Apache sudo distribution. I am giving name is Apache sudo distribution, and it is installing in C drive. Instead of installing in C drive, you can create a separate folder in different drive, because if you install everything in C drive, while restarting, Windows will take longer time. So it is recommended to install in separate drive. So I'm browsing. I'm installing in F drive. I have softwares folder here. Under softwares, I have created VM. In this VM, I created VMware. Here I'm going to create one more folder saying Apache sudo distribution. I'm creating Apache sudo distribution. Just select that name. Okay, click on OK. Then click on next. Minimum it requires 30 GB RAM. Sorry, hard disk space. So select type 30 GB. See, I'm installing in F drive, right? In F drive, if 30 GB hard disk is not available, then what will happen? Can anyone guess? If F drive doesn't have 30 GB, what will happen? Can anyone guess? Is operating system will install, or is operating system installation will give error? Can anyone guess and tell me? Sure, it will install. Operating system will get error, gives error message. It will install, friends. It will install. Even your F drive doesn't have 30 GB hard disk space, it will install, because installation will take just a 1 GB or less than 1 GB. Installation will take less than 1 GB or 1 GB space. After installation, it will span a maximum 30 GB. So that's what we are giving here. Okay. Okay. Click on next. And here, click on customize hardware. If you forgot to click on customize hardware, we can change properties later. Click on finish. So this is Apache distribution Hadoop. What I'm doing, I'm creating separate directory here. So I'm creating new folder saying Apache Hadoop admin, Apache Hadoop admin. I'm moving this folder to Apache admin folder because we are creating complete Apache Hadoop admin related. Okay. So here, click on this Apache pseudo distribution link. Then here you see edit virtual machine settings. So default it is allocated 1 GB RAM, but I want to allocate 2 GB RAM because we are installing DVD ISO, right? So DVD ISO complete contain graphical user interface. So graphical user interface occupies more memory space. That's why it is recommended to allocate 2 GB RAM. So processor minimum 1 and hard disk we allocated 30 GB. Okay. And CD DVD, select this CD DVD, select use ISO and browse ISO file which you have downloaded earlier. Click on browse. In my system, I have CentOS in this F drive software. So I'm selecting DVD ISO. Click on DVD ISO. Click on open. Okay. Go to network adapter. Select bridge. Why we are selecting bridge? I will explain later. So it is recommended to select bridge. Okay. So click on OK. Then click on power on virtual machine. Power on virtual machine. Here we choose some options. So select install CentOS 7. Install CentOS 7. This control alt to come out from this VMware. And this one is to make full screen. Here we select some options. Let's see. And I'm expecting everyone do this in your system. Okay, select the default English language. Click on continue. Click on date and time. Select a country. So I'm selecting India. Click on done. And here, click on software selection. Here, click on server with GUI. Okay. Click on done. Okay. Click on this installation source. Click on installation source. Okay. No need. and click on installation destination. It is selected. Click one time, again click one more time, then click on done, and here click on network and host name. Click on button. It will generate IP address dynamically, and here I am giving mission name, computer name. I am giving Apache dot sudo dot C family computers. C family computers. Computer name can be any name. Click on apply. Okay. Click on done. Then click on begin installation. Then give password for root. Password for root. Click on done. Create user. I said we can create user at the time of installation, right? Here, click on user. I'm giving Hadoop. Username is Hadoop. Making this user as an administrator and giving password. Okay. Click on done. Click on done. That's it. So it is installing operating system. It is installing operating system. It will take some time to install operating system. Okay. So once installation is completed, next we will install other pre-installation step, that is Java installation. In tomorrow class, I will show you how to install Java in our CentOS system. Okay. So that's it for today. If you have any doubts, please let me know so that I will explain. Yep. Here, one of our friend question is, instead of using laptop and VM configuration, can we use Amazon EMR for Hadoop learning? Yes, we can, but it is they will charge money. We can create EC2 instance. In EC2 instance with CentOS, you can try Hadoop installation in that mission. Instead of that one, try to practice in virtual mission so that you will get clear understanding. Later, you can go for cloud. Okay. Yep, we can install in cloud. Yep, I can. Okay. So that's it for today class. We will continue tomorrow and we will discuss. Okay. Thank you. We'll meet tomorrow. Let's start. In previous class, we started discussing types of installation, Apache Hadoop installation. So in types of installation, we have local or standalone mode installation, pseudo distribution mode installation, and fully distribution mode installation. And we discussed what is local or standalone mode installation, and we discussed what is pseudo distribution mode installation, and we discussed what is fully distributed mode discussion. So this is the diagram, right? We discussed. So generally, Hadoop installed on top of JVM, JVM installed on top of operating system. Yes or no? So in local mode, all daemons runs on single JVM. In pseudo distribution mode, each daemon runs on separate JVM. In fully distribution mode, each daemon runs on separate machine. So all master daemons runs on separate machine. Slave daemons like data node and node manager or task tracker runs on same mission but runs on multiple missions. So we discussed this architecture. Okay. Next, we started discussing pseudo distribution mode installation. In that, we discussed different steps. So, step 1 pre-installation steps, and step 2 installation steps, and step 3 post-installation steps. As part of pre-installation, I said operating system we install, Java we install, we create a separate user, and we install passwordless SSH. So in previous class we discussed what? Step 1 pre-installation steps. As part of pre-installation step, we started installing operating system. Yes or no? So we downloaded VMware Workstation and we installed VMware Workstation as part of operating system installation. Then we downloaded CentOS, right? We downloaded CentOS and we installed CentOS. Okay, so this part is completed. Let's see. So after complete installation, accept license agreement. This one, accept license agreement. Click on done. Okay, click finish configuration. So step 1 pre-installation steps, operating system and VMware is completed. So pre-installation step is completed, step 1, and step 2, step 1 inside step 1. Next we see Java installation. Java installation. So here we see Java 8 installation. Java 8 installation. So once it is accepted license agreement, it will show list of users here. If user is not presented, click on not listed. Sorry. So go to user. So here type user is root and username is password. Sorry. Enter your password. So we are logging into root user. We are logging into CentOS using root user. Once operating system installation is completed, so these three steps are completed in yesterday class. Today we are going to see first operating system installation, sorry, Java installation. Next, we see passwordless SSH creation. Yep, first time only it will show that list of options. Once you selected all those options, next to startup onwards, it going to show that options. Okay, so operating system successfully installed in our virtual machine, virtualization software. Okay, so after completing this one, we can install Java. So we can install Java by using wget command. first download Java, right? So installation part we see download Java. Download Java. So here we have .tar file, .tar file or tz file, and we have .rpm file, .rpm file. So we have two files, .gz file and next one .rpm file. If you use tz file, we have to do many configurations, many configurations, many configurations using alternatives keyword, alternatives keyword. Okay, if you use uh, rpm file, we use m command to install, m command to install. Okay, so to download to download to download to download either tzz file dot tzz file or .rpm file, to download either tzz file or .rpm file, we can use wget command, or download in Windows, then move to Linux using WinSCP. So you can download software using wget command or download using WinSCP in Windows. Sorry, download in Windows, then move that files using WinSCP. Okay, first step we are seeing. So here we are downloading in Windows, and move using WinSCP. We are going to see move using WinSCP. Okay, so let's see. Go to Oracle website. Go to Oracle website. Go to Oracle website. Download Java 8 download. Java 8 download. So as part of this one, we are seeing Java 8 download, right? So go to Google, search Java 8 download, click on first link, Oracle website link. Here you will see latest version of Oracle. So first accept license agreement. Okay, here it is showing Linux is supported as well as Solar is supported and Windows supported and Mac operating system supported. Okay, so here I want to download Windows supported, that to 64-bit supported. So we have Linux x64 2. In that, if you observe, one is RPM file, one is tar.gz file. We want RPM file. Let's click on this RPM file. Okay, it is downloaded. It is downloading into some location. Next, we need WinSCP software. WinSCP software to move this file into Linux. So WinSCP is a open source. WinSCP not open. I don't know whether it is open source or not. It is free. It is free. So no need to pay any license. So it uses SCP protocol to move files. SCP stands for secure copy protocol. Okay, so download WinSCP, it is free. Download WinSCP download. So go to WinSCP official website. This is very important for us. So click on download WinSCP. It's 9.1 MB. So once downloaded, install WinSCP. You will see icon like this. So this is WinSCP icon. Okay. So once we have WinSCP icon, click on WinSCP icon. I don't want the latest version. I want to continue with the same version. So here it will ask username and password. So click on new suite. Here it will ask computer name or domain name or host name or IP address. So enter IP address, enter username and enter password. Then click on login. It will connect to Linux machine. So first we need IP address of our machine. Okay. So go to here, our Linux machine. Then see, currently on desktop there is no JDK, right? Once we move using WinSCP, we will see JDK RPM file. So click on open terminal. Type ifconfig. Ifconfig means interface config. It will display interface configuration. Okay. So here, this is our computer IP address. This IP address is generated automatically when we are installing operating system. Yes or no? Later, in fully distribution mode, I will show how to create static IP address, fixed IP address, because this IP address automatically change if you install multiple machines in your VMware. We cannot expect the same IP address is available for this machine. We cannot expect. This is dynamically changed IP address. I will show later in fully distribution mode how to set up fixed IP address or static IP address for our machine. Okay. So use this IP address to connect our machine. So here enter IP address, enter username of that Linux machine, enter password of Linux machine, root user machine. If you want to save this one, click on save, give name Apache Hadoop, sudo distribution mode, right? Sudo. I'm putting name is sudo. Click OK. Then click on login. Yes, add. That's it. If you observe, right side is Linux machine, left side is Windows machine. So in Linux machine, I want to under desktop, I want to place this file. So downloaded file is available under user downloads. So see downloads, under downloads you will see JDK, right? So JDK is downloaded 11th. This is the latest one. So copy, just to drag this file and place this file into Linux machine. So first part download is completed and we moved successfully file into Linux machine. If you observe here, if you minimize, you will see JDK RPM file. Yes or no? team, are you hearing me? We successfully downloaded file and we moved successfully into Linux machine, right? No one is responding. Are you hearing me? So up to first part is okay, right? Download is completed, right? So next part, we see B, install Java. So here we are installing Java by using yum command. So go to terminal, cd desktop, then here yum install -y and jdk version, jdk rpm file. That's it. It will install Java in /usr/java with jdk version, jdk version. Okay, under this you will see different folders. So this is installation path. Okay, let's go and install this one. So here every time, instead of going this mission, instead of going here and doing operations, so I will take linux client linux client to connect linux servers, to connect linux to servers. So we have plenty of linux clients, one putty and two uh, m remote ng. There are many client softwares available in the market. So install putty, download putty. So download putty. So everyone try to download putty. It's my recommendation. Try to get hands-on using putty. Okay, sorry. So first download putty. So you can download .exe file. Then if you click on .exe file, it will open window. So go to Google. So Google is very important. So this website is very important, google.com. If you remember this google.com, it gives 50% of solution. So only next thing we have to know how to search in search bar. So most of software engineers, first point, everyone has to know this address and everyone has to know searching keyword. Then we get to 50% solution. Next onwards, copy paste commands. So next to Control C, Control V, 70% solution. Okay, so here click on download putty. Here you will see download putty. Click on this one. Click here. It will show list of installation files. Don't go for installation files. Go here, putty.exe file. You will see 64-bit putty exe file. So click on this put.exe file. Okay, make place this one in anywhere you require. Then set it as a desktop icon. Desktop icon. Otherwise, go to that location and click on exe file. So you will get exe file. If you click on exe file, it will show here. It is asking host name. So go to find host name or IP address of our mission. So this is IP address, right? Copy this one and paste IP address here. Okay. Here I am giving name Apache Hadoop Sudo, right? Sudo. So save this one. If you want to save username, here there is one option data. Here enter username, root, and if you want to change font size, click on appearance, change font size. So here I am changing font size is 12. Okay, and I want to give, instead of a black screen, I want to give white screen. So use system colors. Then finally go to session, save all configuration details, click on open. Yes, then enter password of root user. Okay, once you enter, go to cd desktop ls command. Here it is seeing rpm file, right? Then I said the next statement install, right? m install -y jdk. So what is the problem is, here it is taking rpm, right? Lengthy name. So let's take rename that one mv jdk and again jdk. So change this lengthy name. Okay, clear ls. Now what we are going to do is m install -y jdk rpm. That's it. Press enter. Started installing this jdk. So if you not enter -y, it will ask multiple times confirmation. If you not enter -y, it will ask multiple times confirmation. So installation is successful. It will install under cd/root/user/user java under java jdk, right? So this is the path pwd. So this is the path ls. Here we see bin and other folders. To make all bin commands available anywhere in our computer, then we set what? Java_home and path variable. So next to C set Java_home, set Java_home and path variable to make all Java commands available anywhere in our computer, in our system. Okay, so for that one we are setting Java_home and path variable. So here in Windows, we set in environment variables. Environment variables, yes or no? In Windows, we set these Java underscore home path variable in environment variables. Is it correct, team? Hello? Do we set Java underscore home and path variable in environment variable or some other location? I'm asking in Windows, friend. Windows environment variable, right? Yes. But in Linux, in Linux, in Linux, in Linux, there are multiple configurations. There are multiple startup files. Startup files. Files. In that, in that, in that dot bash rc. Dot bash rc is by default presented for by default presented for user every user every user every user home directory home directory every user home directory. So if you observe here, for every user home directory under cd/home. Here if you observe ls, for every user it will create one home directory. Hadoop is a user, right? Hadoop is a user, yes or no? We have one installation time, we created one user called Hadoop. Did you remember? Installation time, we created one user Hadoop. So this is the user. If you go cd Hadoop ls hyphen l hyphen a. So hyphen a displays hidden files. Dot any file name. Dot any file name is a hidden file name. So dot bash rc is one file. Dot bash profile is another file. Dot bash underscore logout is another file. So we have three default files. In this one default file called dot bash rc. In this bash rc file, we add this Java underscore home and path variable. So we have a Java is presented under this location, right? Yes or no? So go to that location, cd/usr Java jdk pwd. Copy this path. Just place cursor here. That's it. It will copy nano and dot bash rc. So here we use one more tilde slash dot bash rc. So if you use tilde slash dot bash rc, currently we are in which user, friends? Hello? Currently we are in which user? No one is responding. Superb. So currently we are in root user, right? So some are said correct, some are said wrong. So if you see as prompt, we see root user, right? This one I said in installation time. So if you see has prompt, we can say hash prompt means root user, okay, and dollar prompt means normal user, means normal user prompt, normal user prompt. So by seeing this prompt, we can say we are in root user. Okay. So if we set this path, it will set to root user. It will Java path is available only for root user. But I said we can make one dedicated user for Hadoop, right? So set path in user Hadoop home directory. So for that one, switch user. So switch user. To switch user, we use nano, sorry, not nano. Su is a command. Su username Hadoop. It will switch from root user to normal user. I want to know whether I logged in or I switched to Hadoop user. Then say who am I? If you say who am I, you will get student, right? Same here. If you get who am I, it will give username Hadoop. So next one, nano tilde slash dot bash rc. So go here, type comment java underscore home. There is a command export and type java underscore home equal to pass this path. Oh. So we need Java path, right? Let's open another terminal. cd slash usr slash java slash jdk, okay, pwd. So this is the path. Copy this path and paste here. Okay. Next one, export path equal to $path. This command refers old path colon. It will append Java path dollar Java underscore home slash bin. Bin directory contain all commands. So up to bin path we are setting path variable. That's it. Java home is set. Okay. Once it is set, Control X and Y to save and quit from nano prompt. So once it is set, restart bash rc file bash rc file. So to restart bash rc file, we use command saying source command. This command refreshes path and makes that path available to this terminal. Okay. Now check Java version. Verify Java version. Verify Java version. So if you use verify Java version, go to this link, type java space -version. It is displaying OpenJDK but not Oracle JDK. It is displaying OpenJDK but not Oracle JDK. If still it shows, old version of Java, then use below command to select to select Oracle Java. Okay, so we use command saying alternatives -config -config Java. Okay, use this command alternatives -config Java. Enter this command. Use sudo command to modify that options, because we are using it as a normal user, right? Press enter. So it is showing OpenJDK version is number 1 and Java JDK version number is 2. So star means selected version. Then we want what? 2. Okay. So now type Java space -version. You will see Oracle Java latest version which we have installed. So -alternatives is a command to choose whatever the version we want. It means you can install multiple versions of Java in your machine. By using this command, you can set corresponding version. Okay, you are getting right. So next one. So Java installation is successfully completed. Java installation path is successfully set. Next one,